Hello students, today we are going to solve a simple problems and yes students, here you can see we are going to solve a question paper. Very recently we got this question paper 22 mat yam 21. So look here students, what is the instructions given here? Part A 5 questions, each carries 6 marks. Part B one full question from each unit and each question carry 10 marks. Part C answer any one full question and each carry 20 marks. So let us, without wasting the time, we'll solve this question paper. You can look here the questions come in the exam. This is your part A. First question, directional derivative. Newton's divided difference. U1 for given data. Find the root of the equation cos x is equal to x e raised to x using appropriate method. Correct to 4 decimal places. Partial differential equation. And here we have proved that. And one more we have derived. So this is how we have the question paper here. Let us solve this one by one immediately. So we'll start with our problem solving. First question is find the directional derivative and magnitude of equation psi is equal to x square yz plus 4x z square at 1 minus 2 minus 1 along 2y minus j minus 2k. As we know students that gradient of the vector nebula psi is equal to, we have this formula, even we use this formula, gradient vector psi, we use this formula as rho upon rho x psi I plus rho psi upon rho ij plus rho psi upon rho z k. So this is how we use the formula of directional derivative, and we'll simplify this students now. We'll substitute the values one by one. We'll differentiate this psi with respect to x. When we differentiate this students with respect to x partially, please remember y and z are constant. Only x we are going to differentiate. So x square differentiation is 2x, and in this case it is x differentiation is 1. So please remember here rho psi upon rho x is equal to 2x yz plus 4z square. Similarly, we differentiate this equation with respect to y. When we differentiate partially with respect to y students, x and z remains constant, so differentiation is 0. So here only y differentiation is 1, x square and z will remain as it is, plus this is 0 because there is no y in this 4x z square. Similarly, we will go to this dou psi upon dou z is equal to x square y plus dou x z. So this is when we differentiate with respect to z partially, x and y remains constant. So this is how we simplify the example. Okay. Then now we'll substitute in this formula. So therefore this is 2x yz plus 4 z square I plus x square zj plus x square y plus 8 xz k. So this is how we substitute all these values in your formula. Now look here students, in the directional derivative and to find the magnitude of the equation along 2i minus j minus 2k. Here we can see the values they have given. This is along 1 minus 2 minus 1. So therefore if you take this as nebula of phi, we'll substitute x and y values one by one in the substituting in this formula. Therefore we get here 2, x is 1, y is minus 2, z is minus 1 plus 4, z is minus 1 square. So this is your I component from this equation, plus we'll continue this, x is 1, z is minus 1 j plus x is 1 square, okay, y is minus 2 plus 8, x is 1, z is minus 1 k. So when you simplify this ones, you will get this as 8i minus j minus 10 k. So this is how we calculate the gradient vector at point 1 minus 2 minus 1. Okay. Now as we know the formula for divided difference, students. Here we see the divided difference magnitude will calculate. So please remember the formula for divided difference dd is equal to nabla psi phi into n cap. N cap is nothing but our unit vector. To calculate n cap, or in this case we have taken this as u cap, that is a unit vector. U cap is, in this case we have taken this as in the direction of v. This formula to remember, students. U cap is equal to v bar divided by modulus of v bar. It is a unit vector. So as the unit vector they have given in the direction of 2 minus 1 minus 2 minus 1 minus 2. This is along this direction. So it is along, in the question they have given along 2i minus j minus 2k. Along this we are going to take the vector 2 minus 1 minus 2, substitute in the magnitude of v bar, that is modulus of v bar is equal to square root of, this is, if you consider this as x, y and z, it will be square root of magnitude of v bar will be square root of x square plus y square plus z square. Therefore this will be square root of 2 square plus minus 1 square plus minus 2 square is equal to, this is 3. So therefore we get this as modulus of v bar is equal to 3. As we substitute in the unit vector u bar, we get this equation. Okay, we'll substitute this in our formula. So here we see the formula we have taken for directional derivative. To simplify this, some of them may get confused. Therefore we are going to solve this using the calculator. Yes, students, here you can see, let's use the calculator here. Very simple. On the calculator, students, quickly, then go to the mode setup, go to the vector 8 1, because this is 3 elements are there, so I'll take 1. So here I have to take 8 equal to minus 1 equal to, and then minus 10 equal to. So this is the values of vector A. Now I will go to the values of vector B. Go to shift 5 1, and this is second vector, that is vector B. I will choose 1. So here I am going to take now. As you see, this is 2 by 3, 1 by minus 1 by 3, and this is minus 2 by 3. So 3 is divided. So 3 I will take a common in this, and I will take it outside. And I will take here, this is the numerator value 2 minus 1 minus 2. So I'll just take 2 minus 1 minus 2. Look here in the right hand side, students, carefully that how I am doing in the calculator. I have stored now vector A and vector B. I'll go to now again EC shift vector A is 3. Okay, here we have again shift vector dot product. I'm going to use 7. So if any confusion is there, you can just rewind the video once again. Shift 5 vector B, that is 4. So here you can see vector A into vector B, we get this as 37. And as you see that I have taken the common part from here. In this I have taken 3 as a common part, so 1 by 3. So vector 8 minus 1 minus 10, this is 2 minus, this is I have used dot product, minus 2. Look in this calculator, student, what is the answer? Is 37. Therefore this is equal to 1 divided by 3 into 37, which is equal to 37 by 3. Very quickly you can solve this type of example. So quickly without explanation, go to the next example. Once again we see here, students, the second example in our question paper is given. Notice divided difference formula. Find f of 4 from the given data. X 0 to 3 6, f of x minus 4 to 14 158. Let's solve this example, students, here. Look here, students. So when we take using Newton's divided difference formula to find f of 4 from the given data, this is the data given. Immediately you have to find the Newton's divided difference. Look here carefully, students. I will just take not only the differences of the f of x, but divided by also will take the difference in the intervals. So let us start with 2 minus of minus 4 divided by 2 minus 0, which is equal to 3. Here 14 minus 2 divided by 3 minus 2, which is equal to 12. Similarly 158 minus 14 divided by 6 minus 3 is 48. In the next case we'll take 12 minus 3 divided by this interval 3 minus 0, which is equal to 3. Similarly you take 48 minus 12 divided by 6 minus 2, which is equal to 9. So here we can see very easily, students. Last is 9 minus 3 divided by 6 minus 0, which is equal to 1. So these all values we are going to calculate the first divided difference. Please remember here students, in this case always we take this as our answers 3, 3, 1. This is first divided difference, second divided difference, third divided difference. We'll substitute in the formula. Please remember this formula students. F of x naught is plus f of x naught x1 x minus x naught plus f of x naught x1 x2 x minus x naught x minus x1 plus f of x naught x1 x2 x3 x minus x naught x minus x1 x minus x2. As you can see, they have given only the interval till 3, so we can only find the third interval. Therefore we take only this difference students. Okay, so as we can see, what is given here students? What is x? Yes, please anyone tell me what is x? Yes, the given question here, x is 4. Please remember here students, and we are going to take x naught 0, x1 2, x2 3, and x3 6. Okay, we'll substitute in the formula given below. One by one we'll substitute all the values and we'll find the answer students. Okay, let us start. Yes, we'll substitute one by one. Please remember here students, x we have taken here 4, so therefore we'll start with f of x naught is minus 4 plus, here in the table it is given, in the table it is there, this is your f of x naught. Okay, so plus this value is 3, 4 minus x naught is 0 plus this is 3, again 4 minus 0, this is 4 minus 2 plus this is 1, substitute here, this is 1, x 4 minus 0, 4 minus 2, 4 minus 3. So here you can see the difference is stopped with the first dd. So this is your first dd, this is your second divided difference, and this is your third divided difference. So there does not exist fourth difference, and like this we'll substitute in the formula. So when you substitute in the calculator students quickly, 4 plus, here orally you can see bracket I will take here. This bracket does not exist. I'll take the bracket 3 into 4. Okay, plus again here we have 3 into 4, 4 into 4 minus 2, 2. Okay, this bracket completes. So I'm showing one calculator method how you have to do calculate very fast. 1 into anything is 1 number 4. Let us take this as 4 minus 0 is 4, 4 into 4 minus 2 is 2, 4 minus 3 is 1. So therefore enter. So what is the answer students? You can look in the calculator, we can do it very easily. It is 40. So if any doubt is there, you can go through the rewind the video once again and just see. Yes, here we go with the third example students very quickly. Find u1.4 given data. U they have given, f of u they have given. They are not mentioned which method you have to do. Please remember, in such cases you are going to use the method. We'll solve this example. Newton's forward difference formula. As we can see, x they have asked 1.4. So look at this range 1, 2, 3, 4, 5. You want to find the value between 1 and 2, that is 1.4. If you take this as the range, it is above the range. Above the range is always Newton's forward difference formula you have to use. Therefore, use the table immediately. Populate all the values students 1, 2, 3, 4, 5, 10, 26, 58, 112, 194. And then we'll find out the difference 26 minus 10, 16, 58 minus 26, 32, 112 minus 58, 54, 194 minus 112, 82. Like this we all calculate. And here we'll start with our differences. We'll take this as the first forward difference. This is our second forward difference. This is our third forward difference. And there is no fourth forward difference as it is considered as 0. Substitute in the formula. Please remember this formula. So there are only 3 differences. So I have taken only 3 differences. F of x naught plus p, f of delta, f of x naught plus pp minus 1 upon 2 factorial delta square f naught plus pp minus 1p minus 2 divided by 3 factorial delta cube f naught. And therefore we'll substitute all the values in this students one by one. Because initially it starts with f naught, so we consider this as our f of x naught. Okay, we'll substitute one by one values. This is 10, so we'll start with 10 plus 0.4 p. You know students already the value of p we have to calculate here. So already you know the value of p. P is equal to x minus x naught divided by h. So x is our the given value what we wanted to find, that is 1.4. minus 1, that is our initial value x0. So please remember, this is our, we consider this as x0, 1 divided by h. H intervals are all 1. As you see, the difference between this is h is 1, therefore this is 0.4. So therefore, easily to identify p value, so p is equal to 0.4, substitute here 0.4. 16 is the first divided difference, plus 0.4, 0.4 minus 1 divided by 2. 16 plus 0.4, 0.4 minus 1, 0.4 minus 2 divided by 3 factorial is 6 into the third divided difference is 6. Okay, so how you will calculate, students? As usual, go to the calculator. On the calculator first, quickly substitute the values. 10 plus, you'll take the bracket. Quickly you have to calculate 16 plus, as you can see, this is difference is there, so let me take this difference out. Okay, so we have taken the vectors name. Okay, let me put it in normal. Okay, 10 plus 0.4 into 16 plus, we'll take the divided, it is 0.4, in the bracket it is 0.4 minus 1 into it is 16, below this it is 2. Continue this derivative, it is 0.4. I'm showing in the calculator method because many students they get confused using the calculator. So this is how I have substituted as it is in this calculator. So it is into, so the right hand side you can see I am using the calculator to divide it by 6. Enter. Just see what is the answer. Yes, friends. So the answer here we are going to consider here is 14.864. This is how we have to calculate, students. Then we'll move to the next immediately. The next question is how to find the roots of the equation, appropriate method. Here they have given in this case they have given appropriate method, but normally we use in this case in the fourth question regular false method. Okay, understanding the question that this is regular false method, we'll just use this. And let us put it in calculator. We'll start with the calculator. On the right hand side, can you see the calculator? Yes, here we have the calculator. Let us on the calculator first and then go to mode setup. 7 is the table. F of x is equal to, just type this, cos alpha bracket x minus alpha bracket, so it is right hand bracket, open bracket, into alpha, here we have below e to the power, we get here x. Here is the equation ready. Yes, friends, equal to, let's take equal to 0, start with 0, end with 1. Step size, let us take 0.1. So here we get the tabulated value of corresponding x and f of x. Look here, students, carefully, very carefully, at 0.5 and 0.6 are the positive and negative values. Therefore, f of 0.5, I have to take this as 0.1756. Let us write down. So therefore, I will take here f of 0.5. I will consider this as 0.1756 from our calculator. F of 0.6. We are going to take 0.0 minus 0.093. So you can see this is greater than 0, this is less than 0, condition satisfies. When the condition satisfies, students, write the root of this equation. Therefore, the roots of the equation lies in the interval 0.5 to 0.6. Now I will substitute in the formula x1. The first iteration I am going to take. Let us consider here a is equal to 0.5, b is equal to 0.6. If you consider f of a, it will become 0.1756 and f of b will become here, students, minus 0.093. Just substitute in the calculator. This is in the formula, you can just see it is 0.5. In the bracket it is 0.156 minus f of b, 0.5. Substitute here f of b minus 0.093 minus b, we have taken 0.6, bracket we are going to take f of a 0.1756 divided by, let us take this as minus 0.093 minus 0.1756. So just substitute f of b and f of a and b. Let us put it in calculator. Go to the calculator. On the calculator, students, mode setup 1. Now take the division here, substitute the values. 0.5 bracket minus 0.093 bracket complete minus 0.6 bracket 0.1756 Sorry, 56 bracket complete. In the denominator, minus 0.093 minus 0.1756, and this is equal to, just see here students, yes, here we get it is 0.5. Let's look here students, what we get, 0.5653 5653. Okay, this value we substitute again in the calculator, and we try to find the for 0.565 what we get. Okay, just go to the calculator. Here we have, we take here cos x minus x into e to the power x. This is how we have to calculate. Calc to last x value is now 0.5653. Yes, once you can see, this is this point, but 3 is there, so 0.05037 we get. So it is a positive value. Okay, for the term 0.5653. Okay, substitute now. Let us take this as positive value. Again, when you put calcium, now which is closer, students, we'll write down here. Therefore, f of 0.5653 we get 0.05037, which is again positive value, and therefore let us take and f of 0.6 is equal to minus 0.093, which is negative value. Again, the condition satisfies, students. Let us take this as now a, b, this is f of a, and this is f of b. Substitute in the formula x2. So therefore x2 is equal to b a by 6.3. F of b is minus 0.093 minus 0.6 0.0503 divided by minus 0.093 minus 0.0503. Let us put it in calculator and just check the value. Again, go to mode of on. Substitute the value 0.5653 bracket minus 0.093 minus 0.6 0.0503 divided by minus 0.093 minus 0.0503, and the answer is 0.57748. So here we get the approximate answer 0.57748. Okay, when you get this value, we'll write here 0.57748. Now we'll simplify f of 0.57748. What is it? Value, students, put it in calculator. Go to the calculator. Press on. Go with the first one, that is cos x again. Cos x minus x into e to the power x calcium. Substitute the values. Minus 0.57748. Yes, so it is minus 0.0288. So therefore, we'll take the value minus 0.0288. So therefore, the answer I'm going to take here minus 0.0288. And like this, we'll come across an approximation. Now look here, we are very close to the answer now. So therefore, we'll end up with this. Or you want, you can go with the one more approximation. Already we have reached the approximation very close. Therefore, we say the roots lies between these two values, and you can continue with x3 like this, and it will reach to 0.5178. So this is the required root of the equation. So this is how we have to solve the example, students, very quickly. Now we'll go to the question paper, students. Once again, what is the next question? We'll just check. Next question we have here, partial differential equations. Yes, students. Look at the partial differential equations, eliminating the value. How you're going to eliminate this, students? Yes, come here again. We simplify this. So look at this question. First, you write down this question. The given arbitrary function, what they have given here, arbitrary function. Let us take the arbitrary function z is equal to e raised to ax plus by f of ax minus by. So one by one, we'll differentiate this with respect to x and y. We'll find the arbitrary function. So first, we differentiate with respect to x, and then we'll differentiate with respect to y. Then we see p and q value. Please remember the formula for p. It is dou z upon dou x, which is equal to, we are differentiating with respect to x, keeping y constant. Therefore, differentiate for this is u and v I'm going to consider. So first, I will keep e raised to ax plus by as it is. Differentiate this f dash of ax minus by. So inner differentiation again I'm going to do with respect to x. That will be x minus by. Okay, then plus. Now I will keep f of ax minus by as it is. So let us keep f of ax minus by as it is. I will differentiate now u using the rule, students. Differentiation. So u into v rule. Keep u as it is. Differentiate v, and keep v as it is. Differentiate u. So the simple rule I'm going to use. With respect to function, this will be, so differentiation of this will be ax plus by. So again, I'm going to differentiate this with respect to ax plus by. So using the chain rule, so the simplification will be e to the power x plus by f dash of ax minus by into a. Yes, students, differentiation of this is, because x is only variable, this is constant, so therefore you don't get this. You give this as 0, then plus. Now this remains as it is. F of ax minus by remains as it is. E raised to ax minus by. Differentiation with respect to x, again in this case, please remember, take only a, whereas to differentiate with respect to x, y remains constant. Similarly, with respect to q, we are going to differentiate now. You take q is equal to dou z upon dou y. Keeping in the mind u into v rule, I will take now first ax plus by as it is. I will differentiate this f dash ax minus by. As you can see, the inner differentiation with respect to y, keeping x constant, so this will become 0, then only y minus b will remain, plus b. Now I will differentiate e to the power x plus by. So again differentiation will be b e to the power ax plus by. F of ax minus by remains as it is. We have differentiated this, and this I have differentiated here, students. Now this, both the values I'm going to substitute in the function. Look at this equation, students. E to the power x plus by into e f ax minus by. This is actually z. Let me substitute this as z. So this value I can write it this as a e to the power x plus by f dash of ax minus by. Okay, plus this value is again z, so this is, we'll write this as directly a z. Similarly, e to the power a, this is minus b, I will take x plus by f dash of ax minus by, plus this value is z, so this is bz. I will write. Now I will substitute in the partial differential equation, that is, we know that b dou z upon dou x plus a dou z upon dou y, which is equal to, just multiplying b to dou z upon dou x. This is here dou z upon dou x. That is our p, and a I'm going to multiply in this equation. You can easily identify that this is 2abz. So you can just see this and this terms will get cancelled, and this will remain only, this will remain abz plus abz will remain, which is equal to 2abz, which is the required PD. This is how we have to simplify the partial differential equation. We have eliminated the functions. This is the final answer. Dear students, please remember derivation of heat equation. Already I have done in my previous lecture. This is the introduction to applications of partial differential equations. One dimensional heat equation. Consider the homogeneous bar on uniform cross section. Suppose that the sides are covered with a material impervious to heat, so that the streamline of the heat flow are all parallel and perpendicular to the area alpha. Take one end of the bar as the origin and the direction of flow as the positive x-axis. Let rho with the density, S with the specific heat, and K with the thermal conductivity. This is the diagram we have to show. It's already done in my previous video lecture. So this is the derivation we have to write. With this, please remember, we have the solutions of heat equation, but that is not asked in the question. So what you have to remember: method, equation you have to remember, formula, boundary conditions, reduce the equations, and general solutions. We have already solved examples on this. in my previous video. Just like and subscribe, students. You can see one more derivation is that not only heat equation, students, but also wave equation. Yes, this is one dimensional wave equation, vibration of a stress string. Even this is I have derived in my previous video. You can go through the YouTube channel and just check the one dimensional wave equation. This is the solution for one dimensional wave equation. What not only that, students, we suppose these are the examples I have solved in my previous lectures. Yes, students, thank you so much.